Physics does not forbid time travel. That is not a metaphor, and it is not science fiction. It is the conclusion that falls out of the equations directly. The same equations that run the GPS in your phone, the same equations that predicted black holes before we ever saw one, the same equations confirmed to such precision that they are the most tested theoretical framework in the history of science. General relativity, quantum mechanics, special relativity. These are not speculation. These are the operating system of reality. And buried inside them, confirmed at every experimental test we have ever run, are 6 mechanisms by which time travel is not only permitted, it is described. In some cases, it is already happening. What physicists have found is not reassuring. The deeper they dig into the mathematics of confirmed physical law, the more time travel appears not as an exotic exception, but as a natural consequence, a structural feature of reality they cannot remove without unraveling everything else. In this investigation, we are going to examine 6 methods of time travel that exist inside confirmed physics, from the one you are experiencing right now to the one that makes causality itself optional. Number 6. Moving clocks run slow. This is not a quirk of measurement. It is not an artifact of the instruments. In 1971, physicists Joseph Haefel and Richard Keating flew cesium atomic clocks around the world on commercial aircraft and compared them to identical clocks left on the ground. The airborne clocks lost nanoseconds, not because the flight interfered with them mechanically, because time itself passed more slowly for an object in motion. Exactly as Einstein's special relativity predicted in 1905, the effect scales with speed. At 99.9% of the speed of light, a traveler ages 22 times slower than someone standing still. Send a person on a round trip at near light speed, lasting what feels to them like 1 year, and they return to a civilization that has aged 22 years without them. They have traveled 21 years into the future. This is not theoretical. Muons, subatomic particles created when cosmic rays strike the upper atmosphere, travel at 99.7% of the speed of light and survive long enough to reach Earth's surface. By classical physics, they should decay in microseconds, long before reaching the ground. They don't. Their internal time is running slow relative to ours. This is confirmed in particle detectors worldwide. Your GPS corrects for this every day. Satellite clocks moving at orbital velocity run 7 microseconds slow per day due to their speed alone. Without accounting for this, positioning would drift. Engineers account for it because it is real. Time travel to the future is not pending, it is already occurring. Number 5, the more extreme mechanism, gravity. Gravity is not a force pulling objects together. It is a curvature of spacetime itself. And in curved spacetime, time passes more slowly. This is general relativity, and it has been confirmed with engineering precision. GPS satellites orbit at an altitude of 20,000 kilometers, where Earth's gravitational pull is weaker. Weaker gravity means less spacetime curvature. Less curvature means time moves faster. Those satellite clocks run 45 microseconds fast per day relative to ground-level clocks. Without correcting for this, GPS positioning would drift by 10 kilometers every 24 hours. The correction is not optional, it is baked into the system. Now scale this up. Near the event horizon of a stellar black hole, a collapsed star where gravity becomes so extreme that not even light escapes, the time dilation approaches the absolute. For an observer hovering just above the event horizon, 1 hour might correspond to thousands of years passing for a distant observer. In 2019, the Event Horizon Telescope produced the first direct image of a black hole's shadow. M87 star, a mass equivalent to 6.5 billion suns. In 2015, LIGO detected gravitational waves produced by 2 black holes merging, confirming the space-time curvature these calculations require. The mathematics that runs your navigation app is the same mathematics that predicts this. The same equations, the same confirmations. A traveler who orbits a sufficiently massive black hole for a single year returns to a future that has aged by centuries. This is a confirmed geometric property of spacetime, not a prediction, a property. Number 4. What happens when you don't orbit the black hole, but tunnel through it? In 1935, Albert Einstein and Nathan Rosen were working through the mathematics of their own theory when they found something disturbing inside the equations. General relativity permitted a structure, a bridge connecting 2 separate regions of spacetime. Not 2 regions of space, 2 regions of spacetime. The same variable that encodes position encodes time. An Einstein-Rosen bridge, now called a wormhole, is not just a shortcut across space, it is a shortcut across when. For decades, this was treated as a mathematical curiosity. Then in 1988, Kip Thorne, who received the 2017 Nobel Prize in Physics for his work on gravitational waves, published a peer-reviewed paper demonstrating that general relativity permits traversable wormholes in principle. What would keep one from collapsing? Exotic matter, matter with negative energy density. This is where the mathematics meets confirmed experiment. The Casimir effect, demonstrated in laboratory conditions, shows that the quantum vacuum between two closely spaced metal plates generates a measurable negative energy density. Small, but real. Negative energy exists. In 2013, physicists Juan Maldacena and Leonard Susskind proposed the ER equals EPR conjecture, that quantum entanglement and Einstein-Rosen bridges may be the same phenomenon. Every pair of entangled particles might already be connected by a microscopic wormhole. The equations that correctly predicted every confirmed property of black holes say traversable wormholes are permitted. Physicists have not proven they are impossible. They have only found them difficult. Number 3. The method that troubled Einstein most. In 1949, Kurt Gödel submitted a paper to a volume celebrating Einstein's 70th birthday. He had found a new exact solution to Einstein's field equations, a rotating universe. And inside that rotating universe, certain paths through spacetime curved back on themselves in complete loops. A traveler following such a path would return to their own past. Einstein is reported to have called the result a serious problem for his theory. Not that it was wrong, that it allowed time travel to the past. The problem did not go away. In 1963, Roy Kerr solved Einstein's equations for a rotating black hole. The Kerr metric, the accepted mathematical description of essentially every real black hole which rotates, contains closed, time-like curves. The mathematics of rotating black holes describes regions where the past is geometrically accessible. In 1974, Frank Tipler showed that an infinitely long, dense, rapidly rotating cylinder of matter would generate closed, time-like curves in the surrounding spacetime. In 1992, Stephen Hawking proposed the chronology protection conjecture, arguing that quantum effects would prevent closed, time-like curves from forming. That conjecture has never been proven. The equations do not say time loops are forbidden. The equations say they exist. Number 2. Where the laboratory confirms what the theory suggests. In 1978, physicist John Wheeler proposed an experiment that should, by classical logic, be impossible. A photon is fired toward a double slit. Whether it behaves as a wave or a particle depends on how it is observed. Wheeler asked, what if the measurement choice is made after the photon has already passed through the slit? The answer came from confirmed experiment. The photon's past behavior depends on a decision made after it has already traveled through the apparatus. The future reaches back and determines what happened. In 2000, a team led by Yoon Ho Kim published results in Physical Review Letters confirming the delayed choice quantum eraser. Photons, whose which path information is erased after detection, retroactively produce interference patterns that did not appear when the path information was preserved. A measurement of the future changed what happened in the past. This is a peer-reviewed experimental result. Physicist Yakir Aharonov developed the two-state vector formalism, a mathematical framework treating quantum systems as determined simultaneously by both their past and future boundary conditions. It is consistent with all confirmed experimental results. It requires that the future is causally active on the past. A 2023 paper from the Perimeter Institute demonstrated that quantum retrocausality is compatible with relativistic quantum field theory without violating known causality constraints. The past is not fixed. At the quantum level, it is a collaborative product of what came before and what comes after. Number 1. The method that doesn't tunnel through spacetime. The method that moves spacetime itself. In 1994, Mexican physicist Miguel Alcubierre published a paper in the journal Classical and Quantum Gravity. He had found that nothing in general relativity forbids a bubble of flat spacetime from moving faster than light, not the spacecraft inside the bubble. Space contracts ahead of it and expands behind it. The ship sits motionless inside a wave of spacetime moving at any speed the geometry permits. The universe is already doing this. The accelerating expansion of space, confirmed by observations of distant supernovae that earned the 2011 Nobel Prize in Physics, means regions beyond a certain distance are receding from us faster than light. not because they are moving through space, because space itself is expanding between us and them. Alcubierre used the same mechanism, the same mathematics, the same confirmed physics. A traveler inside the bubble experiences no acceleration, no time dilation, no violation of local physics. They arrive before light from their departure could reach the destination. In 2021, physicist Eric Lentz at the University of Göttingen published a modified warp solution potentially achievable using positive energy configurations without exotic matter. Papers from NASA's EagleWorks laboratory reduced the exotic matter requirements from Jupiter mass to potentially sub-gram quantities through geometric modification of the field configuration. General relativity does not forbid this, it describes it. These are not fringe ideas. They are exact solutions to the equations that run the GPS in your pocket, that predicted the gravitational waves measured by LIGO, that correctly describe the behavior of particles tested in colliders every day. The mathematics that governs confirmed reality contains within its structure 6 distinct mechanisms by which time is not fixed. We already know that time passes at different rates depending on speed and gravity. This is engineered into satellite navigation systems on Earth right now. The further down you go, toward wormholes, closed time-like curves, retrocausal quantum experiments, and warp geometries, the less confirmed. But in every case, the equations permit it. In most cases, they predict it. What separates us from these methods is not physics. Physics is already on board. What separates us is energy, scale, and engineering, barriers that are technological, not fundamental. Stephen Hawking spent years arguing that the universe protects its own timeline. He called it the chronology protection conjecture. He never proved it. What we are left with is a set of confirmed equations that contain time travel inside them, pointing at mechanisms we do not yet know how to build, inside a universe we do not fully understand. The question has always been when, not whether. And the most unsettling answer physics can offer is, we don't know.